Alrighty, hello everyone. So I'm working on a project called 8Keep to play on 8 kilohertz polling in the keyboard. So I'm going to be making a custom wireless mechanical keyboard with an 8 kilohertz polling rate. So what that means is the rate at which keystrokes are actually sent to the computer and they update in real time. Basically, the faster the better, especially for mechanical keyboards or um, intensive applications like gaming and things like that, where every single millisecond matters. I also want to make it battery powered, so it can be a rechargeable, have a rechargeable lithium polymer battery inside. And I also want it to be compatible with both vintage and modern switches. So I'll get into what that means a little bit later. And also I designed a custom layout for the board, where every switch is going to be fully programmable, so you can redefine what every single switch does. And this is most notable for the two columns on the left. So there are a few design choices that I chose to include. So one of these is a custom XT layout, which is the two columns on the left. Allows for a lot of the most important keys to be easily accessed while saving desk space. And this is especially important because of the flat nature of this board, which doesn't include the function bar on the top. It kind of lets you put the keyboard in front of your laptop if you have a very shallow desk. In addition, I want this to have vintage and modern switch compatibility. And so what that means is that I want people to be able to use modern Cherry MX switches and the footprint associated with those, as well as older SMK switches, which I have a keyboard for, and I want to find a usage for these switches. In addition, I chose an NRF 5340 microcontroller module because it just comes with everything that I need. And also I'm adding every switch has a diode, which allows for N key rollover, which means that you can have as many keys as you want pressed down and you'll be able to detect them. And then in addition, I made switch cutouts for the usage of the extra PCBs that I have to order, just as part of like ordering PCBs where you get a minimum of like 5 PCBs that you have to order. And so I figured I'd design a little cutout so I could use the extra PCBs as plates to hold the switches steady and aligned when I'm soldering. So here's the progress. You can pause if you want to take a look at the other stuff. I didn't really change anything past milestone 4, I think. So still working on milestone 3 and milestone 2. And then here's the bill of materials so far. But yeah. And then for market research, so this is really targeting the custom keyboard / high-end gaming peripherals market, which to my surprise has a market size of $1.3 billion. And so I'd be competing with companies like Logitech, Razer, HyperX, SteelSeries. If you game, you probably heard of those. If you haven't, then they're pretty high-end desktop peripheral manufacturers, and they make good devices. But overall, from other market research interviews, I've realized a few things. So on the technical side, people seem pretty fine in general with soldered switches, as long as the switches themselves are good and they're reliable. In addition, for the actual wireless implementation, people seem to care more about the reliability of the implementation, and then the latency of said implementation, and then the distance at which they can operate wirelessly. For a lot of people, if it was shorter than a certain distance, then they honestly would just rather prefer having a wire connected to the keyboard. But for the sake of the project, we wanted to include something wireless, so I'm going to try to achieve that. And then finally for usability, having a wire to charge the keyboard every day basically means that the wire will be plugged in all the time. And so this is something that was touched on. And also for power consumption, I'm going to need to implement different modes. For example, for a general office use, I don't need to accelerate the polling rate as much, and so it'll consume less battery for just regular typing. Finally, for a new and useful thing that I found, so when I was looking for microcontrollers, obviously the ESP32 came to mind very much because it comes with a bunch of GPIO and it also has a native Wi-Fi and Bluetooth support on the modules that we have. But unfortunately, the Bluetooth protocol for keyboards is very high latency, and what this means is that because it only supports a polling rate of I think 250 Hz, it takes a while for keystrokes to register when you actually input them. And so what this means is that I needed to find a microcontroller that supported a proprietary 2.4 gigahertz wireless stack. And so what this would allow me to do is write a very low-level and custom wireless protocol that could send over just a few bytes of data at a time, but at a very, very fast rate, rather than Bluetooth, which sends over a lot of data at a slower frequency. So with that being said, I found the NRF5340, which is a microcontroller by Nordic Semiconductor. They're really expensive, but they have a ton of different capabilities: Bluetooth Low Energy, Zigbee, Thread. It has 2 dual-core ARM processors, a 2.4 GHz proprietary stack just built into it, 48 or more GPIOs depending on what footprint you get or what package. It comes with SPI, I2C, UART, everything basically that you would ever need in a microcontroller. I think the only thing that doesn't really come with is, I honestly don't know. I think it comes with basically everything. Maybe, no, it actually does have an analog input. So it literally has a bunch of stuff. And the other thing, so I mean, if you're interested in this sort of stuff where it's like Bluetooth Low Energy, Zigbee, Thread, especially useful for IoT functions or like sensing applications and things like that, where you can combine like 5 different chips into a single microcontroller. Very useful. The other thing is making custom footprints, and as you can see here in the photos, I made a custom footprint for the actual switches for how they attach onto the PCB. And so making custom footprints is really useful because you can do a bunch of things that you wouldn't usually be able to find online if you just downloaded them from DigiKey or SnapEDA. For example, for the switches, just using the extra PCBs for plates is only, I'm only capable of doing that because I made my own custom switch footprint that comes with a cutout. So I can basically just file off these little parts where the vias are and then have a plate that I can use. So yeah, consider doing that if you have something that you want to be really creative with. The mechanical features are very useful in this case. Interesting components. So for example, like literal break-off boards and things like that. So like if a person doesn't need a board, they can just break it off, etc. And then finally, call for help. If anyone has any experience with USB receiver design, it would be great. I would love to get some example projects to take a look at because I'm more experienced with the keyboard side of things, but when it comes to actual receiver, it's a little more difficult. Or experience with Nordic MCUs in general, if you've ever had the opportunity to play around with one, either for like an internship or a personal project. I would also love to get to know just how to get familiar with the SDK and things like that. Or also cool physical designs for the USB receivers. I've seen a lot of designs online already. People have like little cats and stuff that hide all the electronics inside. And so something like that could make just a little, like having the receiver on your desk, if it needs to be that close, a little less jarring than just having like a little black cube that might look out of place. So coming up with ideas for that would be pretty cool. I was also thinking of adding a SPI display somewhere in there. But yeah. So thank you, and I hope to hear from you soon.